Hello, in this video I'm practicing with drawing structural formulas of monocenter molecules with steric numbers between 2 and 6, and I've selected various conformations, one for each combination of electron pair geometry and molecular shape, so each different conformation. Actually, let's move water to the end because we'll just we'll do this one faster without going through the entire process. Boron 3 trichloride. The boron has 3 valence electrons. The steric number is 3 because it will be connected with 3 chlorine atoms. The electron pair geometry will be trigonal planar and the same for the molecular shape. What is the sign for same? I don't know. Okay, and there is no net dipole moment. So let's have a look at this. Oh, no. For example, right now I pressed Control Alt N, cycloroborane, and it did this. This is the shortcut for analysis name. Carbon dioxide. Carbon has 4 valence electrons, and in this case each oxygen will take 2 of them, so we have a steric number of 2. The electron pair geometry will be linear, and molecular same shape the same. Very easy in the beginning. To be honest, it's a bit annoying that I'm seeing all this text over the program for these keyboard shortcuts. And if we would want, we could also make this one a Lewis structure. Triiodide. We have 1 extra electron, right? This is interesting. Iodide has 7 valence electrons, and 2 of them will be taken by iodine. Okay, so we have 5 remaining electrons plus 1 because this is an anion, so we have 6 electrons, therefore 3 electron pairs. With the 2 bonds, the steric number is 5. The electron pair geometry will be trigonal bipyramidal. The molecular shape will be I'm guessing there's something suspicious here. So it has 7 valence electrons, steric number 5, trigonal bipyramidal. Is it linear? Interesting. I think it's linear. Okay. And it seems that there's never a dipole moment. I don't think there is any. I don't know. Let's see. Okay. I'm a bit confused about this one, so let's see. So I'm thinking it's linear, like this. And the 3 electron pairs are form 102 degrees of each other. They are around it, around the central one. So this is also no, it's not here. We have a minus here, right? Because next electron. So see, he always has fancier names than me. Triiodane 2 minus. I have no idea. I'm not good at the nomenclature thingy yet. Is there a dipole moment here? No, I don't see one. But if I'm wrong, tell me in the comment section, please. Let's have a look at these 3 in Chem3D. Okay, this looks nice. Okay. This is linear. Ta-da! Yes. Very satisfying. Even though for small strange molecules the results will often be wrong unless we add some more data. But I will not go into Chem3D stuff today. Oh, what did I do? Okay, so we have the next one is sulfur tetrafluoride. Sulfur tetrafluoride. Sulfur has 6 valence electrons. I think it's below oxygen. Let's see. Yeah. Oh. And 4 of them are taken by this is strange. So 4 of them are taken by again a hypervalence center. So that's a steric number of 5. And the coordination number, maybe we should mention this as well, aka ligancy, is 4. And I will draw it and then explain what this is. For example, the coordination number here is 2 because the central atom has only 2 bonds. In this case it has 4, so the coordination number ligancy is 4. Maybe I should use the shortcut here, not above. Okay, so the electron pair geometry is again trigonal bipyramidal. It is, right? But in this case the molecular shape is CISO, I believe, which has a second name, a synonym for it, disphenoidal. And it's always better to use the fancier name in order to seem more intelligent. So for example, you wouldn't say this molecule is bent in shape. No, you would say it's angular, right? and we'll see about the dipole moment. No, I'm sorry. No, no, no. So we have the sulfur here, the fluoride. And just to make it more clear. So we see here the lambda letter used in naming. That's because sulfur doesn't have the usual number of bonds that it needs, to respect the octet rule. It has 4 bonds instead of the usual 2. If it only had 2, look how the lambda disappears. And it's also adding more fancy naming stuff. But the lambda disappeared, so my prediction was correct. And there is a net dipole moment, right? Fluorine is electronegative, so the net dipole moment would be in this direction. And I will use the dipole arrow. So this is, you right click and you select dipole. Okay, maybe we should also have a look at this. We can't, because this have to move this from away. Yeah, well, as I said, sometimes it needs more data. There's no way it looks like this in space. We could fix it, we could give it more data, but it's not the point today. So we have chlorine tetrafluoride. No, it's a trifluoride. Maybe we should also check this one on Wikipedia, because CISO, yeah, CISO. So for I'm having difficulties with CISO and some other shapes. Okay, chlorine has 7 valence electrons. The steric number is, in this case, 5. No, there's something strange here. So we have the same. Let me check triiodine as well. I3 is linear. Carbon dioxide, of course. So chlorine trifluoride. We have of the electrons 4 remaining, which means 2 electron pairs. The number is 5. And I believe the molecular shape is trigonal pyramidal. I'm sorry, I'm not good at chemistry yet, but I will be in a few years, so stick with me. If I will keep creating videos until I become good in chemistry. Okay, let's see. So in my opinion, we have, how would I draw it so that it looks nice 3D? This, this. Okay. We have electrons floating here, and again lambda because it doesn't have the usual coordination number of 1. So in our case the coordination number is 3 instead of 1. And there is a net dipole moment again. Let's just use the same arrow. Actually, an easier shortcut is just holding control and dragging down, and it creates a copy. Okay, bromine pentafluoride. Bromine pentafluoride. Bromine has 7 valence electrons. 5 of them are taken, plus 1 așa. We have a steric number of 6. The coordination number is 5. The electron pair geometry is octahedral, and the molecular shape will be square pyramidal, and this is not how you write it, and I'm sure there will be a net dipole moment. So let's see. Bromine pentafluoride. No. I've also started playing a lot with computational chemistry. Very fun, even though I have to use Wikipedia a lot, even for what are probably basic concepts, because I do not get them. So there is a net dipole moment towards the axial fluorine. Yeah, I think we can call it that. Net dipole moment towards the axial fluorine. And again, we'll just copy this. Let's test the, actually this is not a proper test. A better test would be to just check Wikipedia and see if it looks correct. No. No, no, no. Let's check fluorine trifluoride. So steric number 5. Fluorine trifluoride. T-shaped. Well, that's not what we have there. So it seems that Chem3D is smarter than us. And yes, yeah, it is T-shaped. Wow. I'm a disappointment to myself. Well, at least the net dipole moment will probably stay the same, so oh my god. Well, that's what happens when you record chemistry practice sessions and you are not a chemist. Okay, let's see, bromine pentafluoride. There's no way Chem3D can show me this properly in space. I'm pretty sure it would need more information. So bromine pentafluoride, square pyramidal. Yeah, let's exactly as I thought. Oh yeah, by the way, I'm learning from a free book from OpenStax called Chemistry Atoms 4 second edition. I'm at chapter 5 right now. I'm also using Wikipedia and the user guides of ChemOffice, which are amazingly written. Sulfur, oh come on, this is easy. Sulfur hexafluoride. Everything is octahedral. Everything octahedral. And I'll just copy this one and change some stuff. Yeah. Okay, let's move on. Sulfur dioxide. Okay, sulfur has 6 valence electrons. There's no net dipole moment here, by the way. Should be obvious. 4 of them are taken by oxygens. 4 of the electrons. So the steric number is 3. We can write the coordination number as well. It's 2 in this case. The electron pair geometry will be trigonal. Trigonal. Planar. And the molecular shape will be bent or angular. Let's see. I don't like how it looks. Also, there's something wrong here. The steric number is 3. Okay. No, it's correct. Let me just bend it a bit. So when I ask him to auto arrange, I don't like this. Anyway, it doesn't matter. Let's check. Sulfur dioxide bent. First, we can name it. Paste it here as well. Did I try for this? I don't know. Okay. Ah, you noob. You pathetic noob. If you only knew. I keep alt tab into the wrong thing. Okay, so we have methane. Oh my god, I keep pressing T, right? T, T, T. Okay. Methane. H4, methane. Steric number and the coordination number are 4. The electron pair geometry will be tetrahedral. This word is difficult to pronounce. The molecular shape the same. And there will be no net dipole moment. Unlike here. Let me just cheat. Oh, I can't. Okay. I should have had the windows showing up. Yeah, this looks trigonal to me. I need to test this one because it's correct. Ammonia. I think it's ammonia NH3. Yeah, because ammonium is NH4, which is a cation. Okay, so the nitrogen, yes. Nitrogen has 5 valence electrons, 3 of them are taken, so that's a steric number of 4. Coordination number is 3. So we have a electron pair geometry tetrahedral. Okay, and the molecular shape will be trigonal planar. Let's think about it. Yeah. How do we make this one? I think like this. And let me also add the pair of electrons. Hopefully it will say ammonia on this one. No, it can be a trigonal planar, right? Because this pair of electrons is pushing the hydrogen bonds down, so yeah. How would you call this one? Trigonal pyramidal? Let's see, then this drawing is bad. Here I will make it again, but let me just... Yeah, this looks more like this. I won't test because this looks too... I like confirmation bias, so I will go with the... That must be correct. Okay, so how do I look? Okay, I will place this one here. It doesn't look 3D to me. Let me think about it. So how do I make it nicely, look nicely? This looks trigonal pyramidal to me. It looks better than what my drawing is actually nicer than this one. Okay, so again we avoided a mistake, so that's great. I avoided a mistake. Let's be serious, no one is actually watching this video. Xenon tetrafluoride, but if someone is watching it, I hope it's helpful, and I also hope that you are pausing each time I'm writing a name and you're doing it yourself first before watching my resolution. If you haven't done that until now, start now. So for the last 3, pause, then do it yourself, and then watch me doing it. Xenon has 8 XE. Xenon, yeah, XE has 8 valence electrons. The steric number is 6. The coordination number is, I keep having different notations. It's not fine. 4. Okay, we're having an obvious square planar here. Yeah, this looks right. And as you can imagine, an electron pushing from above and one from below. Tetrafluoroxenon. This is an interesting information here. So this is a normal valence for xenon, a normal coordination number, because we have no lambda. Let me add the net dipole moment here. So I'm pressing Control and then dragging. And actually, this is the proper direction. Again, hopefully someone will call out my mistakes in the comment section, because I'm trying to learn stuff here. No net dipole moment. Okay, phosphor pentachloride. Go ahead and pause and do it yourself. Phosphorus. Phosphorus has 6 valence electrons. And I will test. Yes. 5. Oh, what? Phosphorus has 6 and. Oh my god. Okay, 5 of them are. There's something strange here. Phosphorus has 5. Yeah, 5. I'm getting a bit tired. Okay, all of them are taking. The steric number and the coordination number are 5. Okay, I know. And the electron pair geometry and the molecular shape are trigonal, bipyramidal. And there is no net dipole moment. I got this one. So basically, when I want to signify an angle that's 120 degrees, I go from the second one, I go down 2 times. When I want it to be 90 degrees, I go once. I don't think this explanation is helpful, to be honest. But whoever is watching this can understand my geometry, and he can easily rediscover it by himself. Okay. No, I won't. Liar. And the last one is water. This one is too easy because I already know it. Electron pair geometry is tetrahedral and the molecular shape is bent or angular. Actually, there's no need, we can just click like this and then press 1 and that's it. And this is not water, of course. Oh my god. And let me place the electrons as well. Ta-da! Saving, and this is it. I will post the document in the video description. By the way, I will post a video with a cool exercise that you should do by yourself and then watch my resolution regarding this type of geometry thinking, molecular shape thinking and electron pair geometry thinking. You will see. So the next video should be that. Bye bye.